Hey everyone, welcome to part 24 of the Pokemon game series in Unity. So in this video, we will improve the architecture of our battle system, which will allow us to solve the limitations of our current architecture, and the new architecture will allow us to implement a lot more advanced features in the future. Special thanks to all my Patreons for making this series possible. By becoming a Patreon, you can support me in the making of the series and get some cool rewards like access to the complete project files of the series. So let's start the video. Alright, so our current implementation of how we run turns in battle system is pretty simple, right? So we have player move and enemy move functions. And if the player Pokemon speed is greater than that of the enemy Pokemon, then we'll go to the action selection state where the player can choose a move. Otherwise, we'll just let the enemy perform the move, right? So it's pretty simple and straightforward. But there are some limitations with this architecture. So let me explain them. So the first limitation is if the enemy Pokemon has higher speed, then it'll attack before the player even gets to choose an action, right? But that's not how it happens in the actual game. The player should be able to do actions like switching Pokemons or using items, even if the enemy Pokemon has a higher speed. So the second limitation is we can't implement move priorities. So with this architecture, we can't implement moves like quick attacks. And then another limitation is that we can't run logics that should happen after both Pokemon's turn are over. And finally, it'll be hard to implement a lot of features in the future like trainer battles and items and all that. So before we start refactoring our current architecture, let me show you how the new architecture is going to look like so you can get some basic idea. So this is going to be our new architecture. So at the start of the battle, we'll always go to the action selection state, and then whichever action we selected, we'll call the run turns function. So run turns will be a core function in our new architecture, and it'll execute the player turn and enemy turn one by one, and it'll decide which turn to run first based on the type of action, the move priority, and the speed of the Pokemon. And once the run turns is over, which means we have executed both the player turn and enemy turn, then we'll go back to the action selection state, and this flow will keep looping. So let's start implementing this new architecture. So in our battle system script, first I'll create an enum called battle action. Alright, so battle actions can be move, switch Pokemon, use item, or run, right? So next, instead of the player move and enemy move functions, we'll create another function called run turns, and this function will take a battle action as the parameter. So this is the action of the player. So right now we don't have to take the enemy action because all the enemy Pokemon can do is perform moves, right? It can't do any other action. So currently we have a battle state called perform move, right? So I'll rename this to running turn, and inside our run turns function, first I'll set the state to running turn. So next I'll check if the player action is actually a move. So if that's the case, then we need to get references to both the player move and the enemy move, right? So we can get the player move from the value of the current move variable, just like we did inside the player move function. So let me just copy that. All right, and I'll store it in a variable called player move. And then we also need to get an enemy move. So for that, we can just use the get random move function of the Pokemon. All right, so I'll name this enemy move. So next we need to check which Pokemon gets the first move. So we'll implement move priorities at the end of this video, but right now let's focus on refactoring the architecture. So right now to decide who goes first, I'll only check the speed of the Pokemon just like before. And I'll create a boolean called player goes first, and its value will be true if the player Pokemon speed is greater than that of the enemy Pokemon, right? Okay, so if the player's speed is greater than that of the enemy, then this will be true, and otherwise it will be false. So next I want to create variables to store the first unit and the second unit. So if player goes first is true, then the first unit will be player unit. Otherwise, the first unit will be enemy unit, right? So similarly, let me also store the second unit in a variable. So in case of second unit, it's going to be opposite. So now we can just call run move for the first unit's move, and then we can call for the second unit's move, right? But our moves are stored in player move and enemy move variables. So we don't know which move belongs to the first unit and which belongs to the second. So one thing we can do is we can store the current move the Pokemon is performing inside the Pokemon class itself. So inside my Pokemon class, okay, under the list of moves, I'll also create a property for the current move. Okay, and in the battle system script, instead of assigning it to new variables, we will assign it to the current move of the Pokemon. Okay, so now to get the move of the first unit, we can use first unit dot Pokemon dot current move, right? So let's actually call run move for the first unit. Okay, so I'll call run move, and the source unit will be first unit, and the target unit will be the second unit. And for the move, we can pass first unit dot Pokemon dot current move. So we have run the first turn, and now we can just run the second turn. But we should really run the second turn if the battle is not over, right? So I'll check if state is equal to battle state dot battle over, and if the battle is over, then I'll just call heal break in order to stop the coroutine, right? And otherwise, I can just go ahead and run the second turn. All right, so I'll just copy the first turn. So for the second turn, the source unit will be the second unit, target unit will be the first unit, and we should pass the move of the second unit, right? Okay, so now we are running the first and second turn one by one. So there is one more thing that I want to change. So inside our run move function, at the end, we are running the on after turn, right? So on after turn is responsible for running all the logic that should happen after a Pokemon's turn, right? So I don't want to put this inside the run move function. Instead, I want to encapsulate this into a separate function. So I'll create a function called run after turn, and it'll take the source unit in the parameter. All right, and I'll paste the on after turn logic inside this function. So the reason why I moved this out of run move is because this should be executed after a turn and not after a move. So in the future, we'll have actions like using items. So on after turn should run after such actions also, right? So let's actually call this inside our run turn function. So after calling the run move, I'll call run after turn. And for the source unit, I'll just pass my first unit. Okay, so we also have to do the same for the second turn. and in this case we'll pass the second unit. So in our run after turn function, there is one more thing that we need to check. We shouldn't run all this if the battle is over, right? It would be weird to take damage from poison after the battle is over. So to prevent that, we'll check if state is equal to battle over, and in that case we'll just stop the coroutine by yield break. Alright, so now inside our handle move selection, when we choose a move, instead of calling player move, we will call run turns. Alright, so for the action, we'll just pass battle action dot move. Alright, so if we look at the player move now, we can see that we don't have any references, so we can safely remove it. So next we are calling the enemy move in two other places, so we also need to remove those. So one place is inside the choose first turn, but we don't need this function anymore since it's handled inside our run turns function. So let me just remove this, and when the battle starts, I'll just go to the action selection state so that player can select an action. Alright, so there's an error at the bottom since we have removed that. So it's inside switch Pokemon. So here we don't need this logic that specifies what to do after switching the Pokemon. Instead, what we'll do is we'll go back to the running turn function and let running turn handle those. So to go back to the running turn, I'll set state back to running turns. So now we don't need this boolean since we are not using it anywhere. So let's actually remove those to keep the code short. Alright, so now inside our run turn function, let's also handle the switch Pokemon action, right? Right now we only handle the move action. So I'll say else if the player action is equal to battle action dot switch Pokemon, then I should just run the logic to switch the Pokemon. So until now we had been doing that directly from the handle party selection function. So in handle party selection, when player selects a Pokemon from the party, then first we'll get a reference to it, and then if it's a valid Pokemon, we'll call the switch Pokemon coroutine, right? So we'll do that from here. So first I'll get a reference to the selected Pokemon, just like we did before, and then we'll call the coroutine to switch the Pokemon, right? So now once the player switches the Pokemon, the enemy will get the turn. So I'll just get a random move for the enemy and run that. Okay, so we just have to run the move. Let me just copy paste the code for that. So the source unit is going to be enemy unit. Target unit is going to be the player unit. And for the move, we can just pass the enemy move. Okay, and we should run after turn on the enemy unit, right? So let's recap what we have done so far. Inside the run turns function, if the player actually chose to perform a move, then we'll run the move of the player Pokemon and the enemy Pokemon one by one based on their speed, right? And if the player chose to switch Pokemon, then first we'll switch the Pokemon and then we'll let the enemy perform the move. Okay, so this is what we have done so far. And by the way, we don't use the enemy move function anymore, so we can just remove that. So next, when the player selects a Pokemon from the party screen, we should actually call run turns instead of switching the Pokemon from there itself. So let's go to our handle party selection function. So here we're directly calling switch Pokemon. So instead of that, we should call the run turns now, right? But there is actually an edge case in case of switching Pokemons. The player might switch Pokemon during his turn, or he might also switch Pokemon if his Pokemon fainted, right? So here, if the player actually chose to switch Pokemon during his turn, then we should call the run turns function. And otherwise, if the player chose to switch Pokemon since its current Pokemon fainted, then we should just do this, right? We should just directly call switch Pokemon. So that is something I didn't show you earlier while explaining the architecture. So we also have a small portion over here. So here, if a Pokemon faints, then we'll go to the party screen and we'll switch the Pokemon. And once we're done with the switching, we'll come back to the run turns function and execute the rest. But if the player decides to switch the Pokemon during the action selection state, then we'll directly call the run turns function, right? So let's actually implement this. So we need to know if it was done during a turn or not, right? So for that, below the battle state, I'll also create another variable called previous state, which stands for the previous state. And inside our handle action selection function, when the player chooses the Pokemon action, before going to the party screen state, I'll set the previous state as the current state, right? So the current state is action selection, and before going to the party screen state, I'll actually store what the previous state was. And inside handle party selection, what I'll do is I'll check if previous state is equal to action selection. Okay, so if the previous state was action selection, it means that player chose to switch Pokemon during his turn. So in that case, we should call run turn function. Okay, and for the player action, I'll pass switch Pokemon. And before doing that, let's actually set previous state to null so that it won't affect the flow next time we come to this function. But we can't actually set previous state to null. So let's actually make previous state nullable. Okay, so back in our handle party selection, what we're doing is if the player chose to switch Pokemon during a turn, then we are calling run turns. And otherwise, if the player actually chose to switch Pokemon because the current one fainted, then we'll just directly call the switch Pokemon function. Okay, so we are almost done with our new architecture, but there is one edge case that we need to handle. Let's say the first unit was the enemy Pokemon, and the enemy Pokemon performed a move which caused the player Pokemon to faint. So right now the battle state will be in the party screen state, and the player will be selecting a Pokemon from the party screen. But during that time, we will execute all the code below the run move function, right? So we need a way to pause the execution and only run all this once the player is done with switching the Pokemon, right? So once the player is done with switching the Pokemon, we'll set the state back to running turn. So what we can do is we can pause the execution if the current state is not running turn, right? So if the state was changed to something like party screen, then we will wait until it return backs to running turn. So the best place to do this is inside the run after turn, since it's called after every turn. So inside the run after turn, to pause the execution, I'll call a coroutine called wait until. So inside this coroutine we can give any condition and it will pause the execution until that condition is true. Alright, so we have to pass the condition as a lambda function, and the condition we want to check is state equal to running turn. Alright, so now after a move, if the state was changed to something like party screen, then we'll pause the execution and we'll wait for the state to return back to running turn, and only after that we will execute all this. So now if the second unit faint after the first unit's move, then inside run after turn we will wait until player switches the fainted Pokemon with another one, right? So by the time we finish executing run after turn, the second unit will be a different Pokemon in case the previous one fainted. So in that case, we actually don't want to run the second turn. It's because current move was actually assigned for the previous Pokemon, right? The previous Pokemon that fainted. And the new Pokemon that was just switched in doesn't have a current move. So we don't want to execute the second turn. So we can check if the second unit fainted. But the problem is by the time we reach here, the second unit will be the newly switched Pokemon, right? So what I'll do is I'll store the Pokemon of the second unit in a variable. So I'll call it second Pokemon, and to it I'll assign second unit dot Pokemon, right? And by the way, here's a mistake I made. So while assigning second unit, if the player goes first is false, I'm actually assigning the first unit, whereas I should have assigned the player unit, right? So yeah, we have the second Pokemon stored inside a variable. So here, before running the second turn, we can check if second Pokemon was fainted. So I'll check if second Pokemon dot HP is less than or equal to 0. Actually, I need to check if it's greater than 0, since we need to check if the Pokemon is not fainted. And we'll only execute the second turn if the second Pokemon is not fainted, right? Alright, so now we have handled all the cases inside run turns. And once we run both the turns, then we can just go back to the action selection state, right? And we should only go back if the state is not equal to battle over. So let me check if state is not equal to battle over. And if that's the case, then I'll go back to action selection, right? So we're done with the implementation of the new architecture. So let's test the game and see if all cases are working. All right, let me start a battle. All right. So if I select a move, Charmander should get the first turn because it has higher speed. Okay, so that's working as we want. So now let's test switching. So if I switch to another Pokemon, you can see that my turn is over and the enemy Pokemon gets a turn. And after that, we are back into the action selection state. So now if I choose a move, the enemy Bulbasaur should get the first turn because it's actually higher level, right? So let's test that. Okay, you can see that enemy Bulbasaur gets the first turn. And let's also test the case when the player Pokemon faints. Okay, so now my Pokemon fainted and I'm back to the party screen. Let me just choose another Pokemon. And yeah, this time I should get the first turn. Okay, so all the cases are working perfectly. So we have implemented a better architecture for our battle system. And in the next video, we will look at how to implement move priorities. So if you think these videos are helpful, please leave a like on the video and consider subscribing to my channel. That will really help me a lot. So I'll see you in the next video.